Back. Properties of Solutions, homework 4.5.
Yeah, this is not a retake. This is, do you be hearing something?
Yeah, something from the speakers. I hope it's not interfering. But anyways, we're doing our practice for this video.
Yes, there's a lot of it. There's 9 of these. Yeah, to the board. I stand into video better. Okay, so finding out how much will not dissolve, I'm going to have to do a little bit of math, okay? What will dissolve versus what's added will give me what did not dissolve. So 120 grams of NaNO3 is added to 100 grams of water at 40 degrees. So let's find my 40 degrees, let's find my 120 grams and plot that, okay? Now, I should be able to dissolve about 105 grams. So 105 grams will dissolve, okay? I'm going to do some subtraction. I added 120 grams. How much didn't dissolve? 15 grams. And if when you're doing this, you do 120 minus 105, I'm okay with that. You're still going to get 15.
How about these? Absolute value sign.
Yeah.
So funny, there's your marker.
Oh, boy. How much did not dissolve? We did it. 15 grams did not dissolve. So let's do the next one. Change the temperature. Ooh, this one's going to be fun. We're going to slide down the curve. Okay? So first, let's figure out where we're at. 110 grams of KNO3. Okay? Yeah, that's the mathematical equation we're going to end up using. We're just going to subtract the two numbers, guys. Okay, so 62 degrees, 110 grams. They should about line up, right? Good. So what happens if I cooled that to 48 degrees? So we'll find 48 degrees, follow it up the line, and see where we end up. Now, see, there's a difference in grams. That difference in grams is 110 minus 180, which is, Monica's going to write this. I think he can do the math himself. Watch.
I just realized there's some Pythagorean theorem maybe going on, but I'm not going there right now.
Yeah, because that's not a triangle, pal. Just saying that's not necessarily a straight line. That one's pretty close, but we're not doing that. No, it's 110 minus 180. So 30 grams dropped out of solution because when I went down to 48 grams, 48 degrees, that solvent can only hold 80 grams of solute. And I had 110 grams in there, so 30 fell out. So when I tell you we're going to play games with this chart, I think you get a feeling for what I'm saying. We've got to be able to manipulate the information that we give it. Okay? Now, it says finding solubility when the amount of solvent is greater or less than 100 grams. This is a classic Regents trick to play on us. That 200 grams is important because notice this chart is based on 100 grams of water. Well, if I have twice the water, do you think I can dissolve twice the stuff? You're right. I can. And here's the other piece. If I have half the water, I can only dissolve half the stuff. So let's find out at 60 degrees how much I should be able to get of KCl in solution. So follow 60 degrees up to KCl. And I see that I can dissolve about 45 grams of KCl in 100 grams of water. So I'm going to multiply it by 2 because now I'm talking about 200 grams of water, right? And now I get 90. Good. I can do 90 grams in 200 grams of water. The answer is 90.
Yep.
The answer is 90. Good.
So
I don't know what you're writing there, but okay.
I was putting my units in because I was being sloppy with my units.
You're good. Next piece. Determine if a solution is saturated, unsaturated, or supersaturated. So we had to figure out which one of those three I am. The answer is going to be one of them. And we learned video 4.0. Above the line, supersaturated. On the line, saturated. Below the line, unsaturated. So let's plot this and see where I come out. 60 grams at 20 degrees is there, and I am under the line. Under the line means unsaturated. I like that those uns match up. Under equals unsaturated. That makes rational sense.
Yep.
Good? Good. Moving on. Now what happens when I add, how much can I add to make it saturated? So apparently I am unsaturated. Mm-hmm. So it says how many grams of KCl are needed to saturate the solution at 50 degrees. So find 50 degrees, go up to KCl, I need to add approximately 42 grams, we'll call it. If you wrote 43, I'm going to give it to you. If you wrote 41, I'm going to give it to you. You're going to see me write that squiggle in front, which mathematically means approximately. Okay? If you wrote 45, you're wrong. If you write 40, you're wrong. There is a range, but you got to be closer, so be careful. Okay? The leeway helps. Find the mass of solute that does not dissolve. This is going to be subtraction now. It says how many grams of NH4Cl will not dissolve if 60 grams is added at 20 degrees. So let's find 60 grams, let's find 20 degrees, and plot that. Now let's compare that to the line of NH4Cl. I should be able to get, it looks like maybe 30, would you say 7 or 38?
38.
38, and I added 60. So the difference between 60 and 38 is something like, 22. So 22 grams of that NH4Cl will remain as a powder on the bottom of the solution, much like the picture we showed you before, where there's solid on the bottom, the top is saturated. Okay, so it won't dissolve anymore. Okay, finding the mass of solute that precipitates when I change the temperature. I like the change of the temperature because this one's I get to slide down the ramp. Okay, like Chutes and Ladders. You never did play Chutes and Ladders, did you guys? Huh. We grew up on it. All right, 60 to 30. So I got to find out 60 grams or 60 degrees. How many grams of NaNO3 can I get in there? Monaco says about 125 grams. But at 30, I can hold 95. So let's subtract the two. 125 minus 95 gives me approximately 30 grams of NaNO3 that will fall out of solution and precipitate as a solid on the bottom of the beaker.
As the temperature changes.
Because the temperature, right, the solvent can only hold 95 grams of solute now at that temperature. So that is not a double replacement reaction that precipitates. That is just the solute going back into the solid phase. Okay, good. Find the mass of solute that could be added after a change in solvent temperature. Okay, good. So another one. So a saturated solution is heated from 30 degrees to 50 degrees. So I'm going to go opposite now. I'm going to heat. So I'm going to start at 30 degrees and go to 50. So at 30 degrees, I can get about, looks like 48 again. I can get 48 grams in. I'm saturated, so I put 48 grams in, right? If I heat it up to 50 degrees, it could hold more like, 84, 85? So now the difference is how much more I could add. So 84 minus 48, very complex math so far in this unit, by the way.
I know.
Really stressing us out. Oh, 4 and 2 is 6, and 40 is 46. 36, got you. It's late in the day for me. 36 grams more I could add. Okay, good? Any questions?
Nope.
All right, good. Phone a friend. I think we've got to be about done here. Find the mass of solute that's dissolved if the solvent mass is other than 100. So I went 50 grams this time
Okay, well,
because I wanted to show both ways.
let me drop some logic on you, son.
All right, drop me some logic.
Well, if I double the amount of the solvent,
I can put in how much more solute.
Double the solute.
Well, what happens if I half the amount of solvent?
Well, it's a 1-to-1 ratio here.
Yeah, I'm going to half the amount of solute that I can do. So first, let's find out how many I can get in 100 grams, and then we'll go from there. So NH3 at 25 degrees. So find 25 degrees, find NH3.
Got it.
Okay, how many grams can I get in of NH3? About 50.
50 grams
So-
per 100.
Now, if I can get in 50 grams in 100 grams of water, how many grams can I get into 50 grams of water? Guess what? It's half.
What's
And
the
half of
equivalent
50
ratio?
is
25 grams.
over 50. The answer is 25 grams. Okay? Monaco's showing you some equivalent math, and
Ratio.
that should be it. You guys got lots of practice, so do your practice. We didn't tell you what practice to do. Do